Yeah, water. Eddie Money. Give me some water, 'cause I shot a man on the Mexican border. Cool, cool water. Give me some water. Give me some water. Look it up. Eddie Money. Give me some water. Good song. 80s music. So good, so good. Oh, look. Okay, what I did is I kept the same things over here, but I changed the circuit around a little bit. Okay, I've got two things on this parallel line here. I added another one in here, so we kind of mix things up a little bit different. But, I mean, just a little bit progression here. Progression. Good. And let's dive in. Let's do it. Let's get our total resistance. So, remember, parallel portions first. If I had, I don't, but if I had another parallel portion out here, like if I had this, we would figure out the resistance here and the resistance here. So each parallel portion is done before anything else. But we'll keep this with one parallel portion here. Okay, one of your worksheets has two parallel portions. Whoa, two parallel portions. Hey, get back here. Oh, it's running away. Where you go? There it is. Hang on. Doggone kids trying to run away. No, I get it. You don't want to watch this stuff. This is fun, though. This is fun. It's another puzzle. Let's solve. This is a puzzle. Let's have fun. P-H-U-N, fun. Okay. So let's get this parallel portion first. Remember, I like to draw in a resistor of a different color that represents the overall or equivalent resistance of these three resistors. That's what I like to do. Just me. Okay? Don't have to. Okay. This line here is parallel to this line here. This line here is going to be added in reciprocal with this line because they're parallel. We add them in reciprocal, remember. Okay, fractions. Love fractions. 4th grade. So fun, so fun. This line here, though, be careful. The trick is most students, if I don't point this out, will do the following. You'll take 1 over 6 plus 1 over 1 plus 1 over 3. Wrong. That's a big mistake. Okay, let's get that out of the way right now. If two things are on the same parallel line, you have to add these together. This line has to be added in reciprocal to this line. This line is 4 ohms. So we add those together. Now we add in reciprocal. We get 1 over 4. Okay, all right. So we add those two together. Okay, so let's do some math. Oh, common denominator. Let's do common denominators. This is fun. I love this stuff. So let's see. 1 out of 6 to 12. 12. Okay, 12. Okay, 12. 6 is going to 2. So that's 2. And then 4 goes into 3. So 3. And that's going to be 5 over 12. That's our answer, right? 5 over 12. Wrong, remember? Flip it. 12 over 5. So reciprocate. 12 divided by 5. 2.4. Who needs a calculator? 2.4. So this is 2.4 sweet ohm fries of resistance in this parallel portion. That's what we have to do first. Okay, now this parallel portion has been determined. The battery thinks there's just one resistor here with the resistance of 2.4. So it's going to send it some voltage. You'll get some and you'll get some. But these, remember, these are both in series, right? These are in series. The electrons, or this way, have to go through these no matter which way we go around the circuit. So it's irrelevant which way we're going. But we have to go through here to get back. We have to go through here to get back. So these are in series. So this is 4 plus 2. We got 6. And now this portion has been determined up here. So this is now considered to be in series. The red is considered in series. So 6, 7, 8.4. 8.4 ohms of total resistance. Nice. Got that. Okay, let's do the total current. Total current is total voltage, 12 divided by total resistance, 8.4. 12 divided by 8.4. You kids relax. It's been a rough day for you. 12 divided by 8.4. Okay, 1.43. So 1.43. Put that right here. 1.43. I hope you learned, and that's amps, that you, from the last video, that the easiest thing to do would now to know that if the total current is known, that has to go through anything in parallel. Boom. Has to go through here. Boom. Nailed it. You have go through you because you're in, did I say parallel? A series. In series. If you're in series, then the current has to go through you. All right, got that one. Oh, look. Oh, that's the voltage. Okay, never mind. Sorry. The current that goes through the 6. Now, the 6 is in parallel up here, so the current's going to come up, the 1.43, and split. Okay, it's going to split and go down here. If you want to think fractions, you could, but I'm not going to go down that road today. This is 4 and 6, total of 10. This is 60%, 40%, so you get 40%, you get 60%. No, okay. I just kind of did that for you, but let's use Ohm's suggestion and figure out what the total amount of current is that would be going through this section and how we're going to split it up. Oh, is there anything else that might be kind of easy to do? I mean, this was easy, right? The current total has to go through anything in parallel, so we got that. We got that going for us. Let's see, anything else easy? The current up here is going to split, so maybe not as easy. The voltage used on the 6, okay, we're not sure about that one either, because we don't know how much voltage used on here. Voltage used on the 2. That's probably the next easiest thing to do. We don't have to do this, but let's do it. This is probably the next easiest thing to do is the voltage used on the 2 ohm resistor here, because this is in series, the voltage is going to be simply the current that has to go through you. Since you're in series, it's the same logic here, that the total current has to go through you. And it's a resistor, it's 2 ohms, so it's a 2 ohm resistor. So just multiply that by 2. And that'll come out to be 2.86. So I know that this resistor right here, the 2 ohm resistor, is using 2.86 volts. 2.6 out of the 12. So there's 12 available, and you get 2.86. Here's what we can do. Let me show you. I didn't show this in the last video, but maybe some of you have seen this. We can now, and actually I think this is actually just as easy, but there's just a little bit more of a brain teaser here, but it's not bad. Let's figure out the voltage that is used on the 6 ohm resistor, and that's actually not that hard. What do you mean? What do you mean? It's like splitting everything. I mean, well, here's the thing. Remember, the battery thinks that there's just one resistor here, and it's going to send it some voltage. So the battery says, okay, I'm going to send you voltage that's going to be equivalent to the current going through you and the resistance of you. Remember, anything in series, the current has to all go through it. So the current 1.43 comes around here. Now the battery thinks, these resistors are snickering and know better, dumb battery. But the battery thinks there's only one resistor here. So the battery says, you 2.14 ohm resistor have the 1.43 going through you. So I will send you, okay, the current going through the 2.14, that's in series now, is 1.43 multiplied by the resistance of this one resistor that the battery thinks is there. That's how much voltage that this section's going to get. This section right here is going to get this voltage. Let's calculate that. See, actually, that wasn't that bad. We probably could have done that right away. But, you know, I was using the same logic on the last one here. Last problem, it's this problem, so I hope maybe that logic connected. But this is just a little slight step up in difficulty, but not much. As long as we realize that the battery thinks there's one thing, so all the current's got to go through it, and it has this resistance, we can get the voltage that's sent to it by the battery. All right, multiply. 1.43 times 2.4, boom! 3.43 volts is how much the battery is sending that resistor that it thinks is just that one resistor. So now here's the thing, and this is the important thing from 2 videos ago. Lines that are parallel get equal amounts of voltage. This line and this line both get the voltage that's sent to this equivalent resistor, which we just determined is 3.43. So you get 3.43, and so does this line down here. So this line here gets 3.43 volts. And so would this line. All right, how much voltage, oops, I put it in the wrong spot. The voltage, not the current. The voltage used on the 6 ohm resistor goes right here, volts. All right, how much current's going through that resistor? Well, now we can do that relatively easy. I know the voltage used on it, and I know its resistance, so let's figure out its current. The current will be equal to, volt is equal to IR, so current's equal to V divided by I. So current is V over R. The voltage that we are now sending to this line from the battery is 3.43. And the current is going to be the voltage divided by the resistance of the 6 ohm resistor. All right. And let's see, we'll take 3.43 and divide it by 6, and we get 0.57. 0.57. Okay, 0.57. So 0.57 amps. 0.57 amps. Okay, now don't think we're done yet. We're not done yet, okay? I got to show you something else here because I didn't realize something I want to show you. But just real quickly, if you did fractions on this, so you get 0.57, and this line here would get the remainder. So 1.43 goes chugga, 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 chew, chew, gets your splits. And so out of the 1.43, you get 0.57, which should make sense. This is more resistance in this line. This line has less resistance, so it'll be faster flow through it. So if we take 1.43 and subtract 0.47, I want some combos, I'm tired. 1.43 minus 0.57 equals 0.883. This should be getting 0.883 amps. Oops, that's a 3. And this line gets the 0.57, which makes sense. This is getting more because it has less resistance. You could have used fractions on this. You could have said, okay, 6 out of the 6 resistance out of a total of 4 here, so it's 10. So 60% and 40%, so you get 60%, because remember, it's going to be opposite. If you have 60% of the resistance, you'll get 40% of the flow. If you have 40% of the resistance, you'll get 60% of the flow. So 60%, 0.6 times 1.43, 1.43 times 0.6 equals 0.86. We have 0.88, so it's just slightly off. The fractions aren't quite as accurate, and that's why what happens the more resistors you get, the fraction starts to break down. It becomes less accurate. So you can do it with 2, but I would not recommend it with 3 or more resistors. Use Ohm's law because that will always be there for you. Okay, so now we've got these done, but I just want to ask one more question. You ready? How much voltage would this 3 ohm resistor get? Now, you know what I just realized? This is like Londonderry colors, right? The heck, red and blue, Londonderry. What the heck am I doing? We bleed red and white every day and every night. Oh, did you get it? Red and white. I got it. Londonderry. All right. So now, voltage through the 3 ohm, no, yeah, that's what I want. Voltage used on the 3 ohm resistor. Now you might say, well, wait a minute, you said that lines that are in parallel get equal amounts of voltage. And if this line got the voltage that this one got, which was 3.43, then this line gets 3.43 and you get 3.43. Wrong. What? This line gets 3.43. Yes. However, the voltage has to be split along the line amongst these 2 resistors. The line gets 3.43, but you guys are different, so you're not going to use the voltage equally. You're going to chew up most of the voltage because you have the most resistance. So how would I get that? Well, okay, the voltage is the current that goes through here, which we calculated to be 0.883. I know I didn't write that down over here, but it's 0.883. That's the current going through you. So the current goes through here, 0.883 times 3. That's the resistance. So 0.883 times 3 will give me the voltage that's used on this resistor. Or the easier way to do it is that this one is 1 ohm times 0.883. So you get 0.883 volts, and you get the difference between 0.883 and 3.43. I know there's a lot of numbers going out here. My brain is like on caffeine right now. I had to get, I'm tired, so I had to go caffeine. I'm flying. Rewind, slow down if you have to. But let's go ahead and calculate this out. 0.883 times 3, so 2.65. So this 3 ohm resistor would use up 2.65 out of the 3.43 volts that was sent to the line. Remember, the lines get equal, but if you have more than one on the line, they got to divvy it up. Okay, it's another example of a combo circuit. And I think our worksheets have a couple of combo circuits. The last year's quiz starts you out with a big combo circuit. Lots of practice that we can do. There's some in the book. Some assignments in the book. If you want more, I can certainly assign more. The assignments I have for this week do include the worksheets and last year's quiz, combo circuits. But there are some out of the book, which I will assign next week. But if you want them this week, you can practice on them. Okay, I think that's it for combo circuits. We are ready. We are ready to roll on. You know what's next? You ready? Okay, listen to this now. Next, we do complex circuits. What? Wait, time out. Tell me, that's not a complex circuit. No. It's a combination circuit, but it's not a complex circuit. Exactly, okay. You got another video coming. You're going to love it.